Next objective is to determine an equation that will calculate the rate of the reaction, specifically for the biochemical or biological reaction catalyzed by enzymes. And we shall write our reaction in terms of our equation. So you have an enzyme, and assuming na mayroon lang siyang isang active site, so you have your enzyme here represented by letter E, and then magre-react within the enzyme's active site yung ating substrate. Okay, now it will form, or this reaction or association will form what we call as an enzyme substrate complex. Okay? Now, this formation could be reversible. So, pwedeng mayroon kang forward reaction, mayroon ka rin namang reverse reaction. The equilibrium constant for the forward reaction, let's call it K1. And for the reverse reaction, tawagin natin siyang K-1. Now, once we have formed the enzyme substrate complex, it will undergo another reaction kung saan it's basically a dissociation reaction kung saan yung enzyme mo ay ma-free up, and then yung product mo ay naging, or rather the substrate now became your product. Okay. Now, if we are going to assume that the first reaction, meaning the formation of the enzyme substrate complex, ay nasa equilibrium, and we will call it rapid equilibrium, what will be the implication? Another thing that we can assume is what will happen if your product formation, okay, or the whole process in general, is in steady state. Okay, so let's do both assumptions. Remember, ang objective natin dito is to determine or to arrive at an equation that will determine the rate or the velocity of the reaction. So, saan tayo magsisimula? Let's write the equation for the speed or rate of the reaction. So, tatawagin natin siyang V. Okay? And then, basically, it's equal to the rate of the change or the concentration of your product with time. Okay, dp dt. Alright, so yan yung ating rate of reaction. Kung gaano nag-change yung product with time, or the concentration of the product with time. Now, if we will call this K2, okay, one moment. So, tatawagin natin itong K2. And then, ang mangyayari sa ating rate of reaction, it's also equal to what? K2 times the concentration of your enzyme substrate complex. Again, the rate is equal to K2, which is the rate constant, times, or rather the equilibrium constant, times the concentration of your enzyme substrate complex. Okay? Now, this K2 is, sometimes we call this in other books as K-cat. Okay, and that means turnover number. Ano ibig sabihin nun? Si turnover number or yung K2, ating constant K2, is number of moles, or rather molecules, converted to product. Okay. Per enzyme site. And then per minute. Okay, so yan yung physical meaning ng turnover number or yung K2, which is the constant right here dito sa ating enzyme substrate complex forming enzyme and the product. So that equilibrium characterized by K2 is the turnover number. So, balikan natin tong equation na to. So the rate of the reaction is change in P with respect to T, which is equal to K2 times the concentration of ES, diba? That's how we write the rate in terms of the reactant and the constant. Now, we can also say that the rate of change of enzyme substrate concentration with respect to time, so based on this relationship or reaction, so the rate of change in the enzyme substrate complex concentration with respect to time is equal to this. So magiging K1 times the concentration of E times the concentration of S. Kasi yung K1 yung constant for the forward reaction. And ano ba yung mga reactants? E and S. Pero since mayroong reverse reaction na possible, so ima-minus natin yung K minus 1 times the concentration of the enzyme substrate complex. And another thing is that from your ES, meron ka pang forward reaction forming the product. So, ibabawas pa natin yung K2 times the concentration of the enzyme substrate complex. Okay? So, bakit minus? Kasi ES complex is being consumed. Ganoon din dun sa reverse reaction kay K minus 1. ES complex is being consumed. Pero kay K1, positive siya kasi ES complex is being formed. Okay? Now, another relationship that we can take note is this. At any given time, the concentration of your enzyme is equal to the initial concentration. So, yung initial concentration siya yung total concentration ng enzyme. Minus yung enzyme na nakakabit dun sa substrate. So, this should make sense, right? Ang ibig sabihin lang nun, yung total or initial concentration mo ng enzyme should be equal to whatever enzyme is free plus whatever enzyme is associated with the substrate. So, we call this, let's just simply call it conservation of enzyme. Now, dito na tayo mag-a-assume ng dalawang conditions. Either we will assume rapid equilibrium or we can assume what we call steady state. So let's try first the rapid equilibrium assumption. So, paano yan? So, si rapid equilibrium assumption, ito yung development or derivation na ginawa nina Michaelis tsaka Minten. I don't know kung ano yung kanilang first name, but ito yung tinatawag nating Michaelis maintain assumption or derivation. So, paano to? Yung ating enzyme substrate complex concentration is equal to the concentration of the enzyme times the concentration of the substrate divided by K minus 1 over K1. So, saan nakuha yan? Dito sa part na to. So, let me probably write this one like E plus S, remember, in equilibrium with the enzyme substrate complex. K1 yung forward, K minus 1 yung reverse. Alright? Therefore, the ratio of K1 and K negative 1, okay, times the concentration of the enzyme substrate complex shall be equal to the product of E and S. Okay, so based on this equilibrium, kaya natin na develop to. Okay? So, ang ibig sabihin lang kasi niyan is from this relationship, diba, meron kang enzyme concentration, substrate concentration times yung kanyang constant K1 should be equal to the rate of the other or the reverse process, which is K minus 1 times the enzyme substrate complex. So, if you're going to arrange this one a little bit, ang mangyayari is you'll be able to derive this relationship. Okay. Ituloy natin kasi yung enzyme substrate complex concentration na yan will be equal to, so what will we do here is gagamitin natin tong relationship na to, which is the conservation of enzyme. Isa-substitute natin yan dito kay enzyme concentration. So magiging initial minus enzyme substrate, okay, times, okay, we're just following this one, divided by K minus 1 over K1. Okay, now let's further simplify this equation. So, yung ating enzyme substrate complex concentration multiplied by K minus 1 over K1 is equal to initial enzyme concentration times substrate concentration minus enzyme substrate concentration times substrate concentration. Okay. Now, anong terms ang mayroong common? So, we say that these two terms may common sa kanilang dalawa. So, ang gagawin natin ay pagsasamahin natin yung dalawang term na yan. So, ang common sa kanila ay yung enzyme substrate concentration. Alright, and then multiplied by K negative 1 over K1 plus substrate concentration equals initial concentration ng enzyme times the substrate concentration. So we can now solve for the enzyme substrate concentration. So ano mangyayari? Magiging initial substrate divided by K minus 1 over K1 plus the substrate concentration. Okay. Now, here are a few things na kailangan nating maintindihan. So, if we again go back to our original equation, which is we are after the rate of the reaction, and again, equal siya, di ba, sa change in product concentration per time. Also, naalala mo kanina yung ating relationship, which is this. K2 times the enzyme substrate complex concentration. So K2 times the enzyme substrate concentration. But we know the enzyme substrate concentration, which is this one. So substitute natin yan. Magiging K2 times initial enzyme concentration substrate divided by K minus 1 over K1 plus the concentration of the substrate. Ngayon, yung K2 times the initial enzyme concentration, so I'm talking about this part. This is actually what we call as the maximum velocity or maximum rate of reaction. Kasi yan yung initial enzyme concentration. Okay? Kumbaga, initially, wala pang nakabind na substrate. So, whatever the velocity of that, yun yung maximum. Okay? Now, another thing is this. This ratio here, yung ratio ni K minus 1 over K1, tawagin natin siyang Km. Or rather, Km prime. Okay? So, if you're going to simplify that based on those substitutions, lumalabas na si rate of reaction will be equal to V max times the substrate concentration divided by Km prime plus the substrate concentration. And this is your final equation if you're going again to use yung tinatawag na nating rapid equilibrium assumption. Now we have determined or derived the rate of the reaction. And if you notice, ang equation na to ay makikita mo na ang kinetics dito ay saturation kinetics na tinatawag. Ano ibig sabihin nun? If you're going to take or plot yung ating substrate concentration versus yung ating velocity, it will follow this equation, and the shape of that curve will look like this. So again, if this is your substrate concentration and this is your velocity or rate of reaction, because of the nature of that equation that we have derived, so parang magiging ganito siya. Ang tawag dyan ay saturation kinetics. So bakit saturation? Kasi your enzymes will be saturated eventually by the substrate. And if they are saturated already, ibig sabihin, maximum na yung velocity. Okay, they will achieve maximum velocity. Ibig sabihin, at higher substrate concentration, masasaturate mo na yung enzymes. Therefore, maximum na lang yung ma-attain mo na velocity. Okay. Number 2, what if ang assumption natin ay yung tinatawag nating quasi-steady state? And si quasi-steady state, ang may pakanaan yan ay sina Briggs and Haldane. Okay? Hindi ko rin alam kung ano yung first name nila. But it's an alternative to the Michaelis-Menten assumption. But ang sinasabi lang naman dito is that yung ating enzyme concentration initially, okay, is very small compared to the initial substrate concentration. Anong implication niyan? So, ang implication lang naman doon is that the change in the enzyme substrate complex with time is equal to 0 or approximately equal to 0. Kaya nga quasi-steady state. Walang accumulation ng enzyme substrate concentration. Okay? So, kung babalikan natin yung equation dito sa taas, which is this one. Okay? Let us copy this. Okay. Kopyahin ko lang yan. Copy. Tapos, paste natin dito. Yan. Ngayon, sabi nga natin, walang change in enzyme substrate concentration with respect to time. Wala. So, ibig sabihin, mag-zero yung left-hand side ng equation na to. Ano may iwan? Ano mangyayari? So, let's see. Kung nag-zero yung left-hand side, sulat natin, 0 equals, so K1 times the enzyme substrate or the enzyme concentration times the substrate concentration minus K minus 1 times the enzyme substrate concentration plus K2 times the enzyme substrate concentration. Alright, so if we arrange the equation, ilalagay ko yung isa sa left-hand side, magiging K1 times concentration of enzyme times the concentration of substrate equals, negative yan dapat, pero gagawin natin positive, gagawin din natin positive yung kabila. And factoring out si ES concentration, ang mangyayari ay ganito. K of plus K cat. Okay, or K minus 1 plus K2. Okay. Now, ang susunod natin gagawin, remember yung idea na I've shown you here, this one. So, the enzyme concentration anytime is equal to the concentration of the initial concentration of your enzyme minus whatever concentration yung na-associate na yung enzyme kay substrate. So, ibig sabihin again is that the total enzyme concentration or the initial enzyme concentration is equal to whatever enzyme is free plus whatever enzyme is associated with substrate. Now, we will substitute that relationship here in our working equation. So, mangyayari ay magiging K1 times initial minus enzyme substrate. Alright? Times substrate. Kasi meron ka pa dong substrate. Equals, kukopiahin lang natin yung kabila. Enzyme substrate concentration, K minus 1 plus K2. Magiging K1 times the enzyme initial concentration, kasi ilalagay ko sa kabila yung isa, no? So, kukupayan ko muna to. K minus 1 plus K2. I forgot to include ES. Tapos, transpose ko yung kanina dito sa right-hand side na magiging plus enzyme substrate concentration times substrate concentration. So, furthermore, ano mangyayari? I forgot here na i-multiply itong substrate concentration. Anyway, what will happen next is we can factor out si ES concentration. Okay? So, magiging K minus 1 plus K2 plus I forgot to include here K1. Okay. Plus K1 times the substrate concentration. Alright. Ngayon, pwede na natin siyang isolve for the enzyme substrate concentration. So, ang kakalabasan, magiging K1 times the initial concentration ng enzyme times the substrate concentration divided by K minus 1 plus K2 plus K1 times the substrate concentration. Okay. Now, ang gagawin ko next is I will divide the equation or rather i-divide ko yung numerator at denominator sa K1. I don't have to of course do that in the left hand side kasi both numerator and denominator gagawin ko naman siya. So ang kakalabasan yung enzyme substrate complex natin concentration mawawala si K1 sa numerator. Saan siya mapupunta? Mapupunta siya dito sa denominator. So, magiging K minus 1 plus K2 over K1 plus substrate concentration. Now, again, kanina sabi natin ang rate of reaction is K2 times the enzyme substrate concentration. Gawin natin yan, K2 times ES is, we have that expression already. So, initial, substrate, then the constants, plus the substrate concentration. And again, this group of constants here, if you remember kanina, in the rapid equilibrium assumption, ganoon din gagawin natin, this is equal to the maximum rate of reaction. And this group of constants here, papangalanan natin siyang Km. Kanina Km prime kay rapid equilibrium assumption, but for quasi-steady state, we will call it Km. So, lumalabas tuloy na ang final equation natin utilizing the quasi-steady state assumption is that the rate of reaction is equal to the maximum velocity times the substrate concentration divided by Km plus the substrate concentration. So, ito yung ating final equation for this particular Briggs-Haldane assumption. And if you notice, it's the same in format with the other approximation in part 1, right? So, it's also a saturation kinetics type of equation. Okay? So, ito yung tinatawag nating, although we use the Briggs-Haldane equation, or Briggs-Haldane assumption, we now call this equation as the Michaelis-Menten equation. Okay? So this now is the final equation. And the thing is, for most circumstances, imposible kasi na ma-differentiate mo si Km kay Km prime. So we'll just have to stick with Km because that is the more general derivation. Okay, so Km na lang ang gagamitin natin. Now, let's further analyze this equation, whether yung first or second assumption, it doesn't matter, they have the same forms, and Km, Km prime, it's difficult to differentiate, so we'll just use Km. So if we're going to analyze these equations, okay, letter A, what if your substrate concentration is low? What will happen? So if your substrate concentration is low, okay, sulat lang natin yung equation ng Michaelis-Menten or Briggs-Haldane if you wanna use that. Okay. Ano mangyayari kapag low substrate concentration? So kapag masyadong mababa yung substrate concentration but you're not assuming zero muna, kumbaga in the numerator it stays, but in the denominator kapag masyadong mababa, so kakancel natin yan. Okay? Pero don't do that in the numerator kasi walang matitira. But anyway, what will happen is magiging Vmax times the substrate concentration over Km. Ano ibig sabihin yan? It means that yung rate V, okay, ang ibig sabihin yan, V depends linearly on the substrate concentration at this condition. So, lumalabas na kapag masyadong mababa yung substrate concentration, para tayong nagkaroon ng first order na reaction. Okay? Now, what if kabaliktaran naman, high substrate concentration naman tayo? So, isulat natin ulit yung equation natin, Michaelis-Menten. What will happen if you have very high substrate concentration? So, kapag masyadong malaki yung concentration ng substrate, parang nanliliit na si Km. Okay? So, kung nanliliit na si Km, para siyang negligible. So, ang lalabas sa ating equation ay what? Maka-cancel mo rin si substrate concentration, right? So, maging V max na lang siya. Anong ibig sabihin yan? Ibig sabihin, your rate of reaction, okay, does not depend on the substrate concentration, but it's equal now to your maximum velocity, which is a constant. So, lumalabas therefore na zero order yung ating reaction kapag masyadong mataas yung substrate concentration. So, if you will show that in a graphical form, okay, which I've shown you a while ago also, this is your substrate concentration, this is your velocity. So, at very small or at very low substrate concentration, okay, sabihin natin yung low is from this point to this point, ay first order daw. Pero dumarating sa point na kapag masyadong mataas na yung concentration ng substrate, nagfa-flatten na siya. And that point, okay, the velocity or rate at that point is what we call your Vmax. So, totally, whether high or low concentration, any concentration of substrate, the kinetics here for the enzymatic reaction is like a combination of a zero order and a first order reaction. But we don't normally call it that. Okay, but it's a kinetic equation or rate law on its own, which is the Michaelis-Menten rate law. Now, I'll have to add here some more information, which is when yung ating rate of reaction is kalahati nung maximum. What will happen? So, let me show you this. If that happens, okay, remember that our equation is V equals V max times S over Km plus S. But V is 1/2 V max. Okay? Or V max over 2 equals V max times S over Km plus S. Ano mangyayari? Both sides of the equation may V max, makacancel yan. So what will remain is 1/2 sa left hand side and this sa right hand side. Okay. So the right hand side of the equation is equal to 1/2. Kailan lang siya mangyayari? Take note, meron kang substrate concentration sa denominator, meron din sa numerator. So mangyayari lang na magi-equal sila kay 1/2 if Km is equal to the substrate concentration. So therefore, ang ibig sabihin lang yan, we have found a way to interpret Km some other way. So ang ibig sabihin, Km is equal to the substrate concentration pala kapag ang rate of reaction mo ay kalahati ng maximum. So, ganun ang ibig sabihin ni Km. Furthermore, Km has something to do with the affinity of the substrate to the enzyme. So, if you have the higher the value of Km, ang ibig sabihin nun is lower affinity of the substrate to the enzyme. So they will have an inverse relationship. The higher the Km, the lower the affinity.